Hey, today we're going to do rotations. So a rotation, we're specifically going to focus on rotations about the origin. So that's going to be a turn around a fixed point called the center of rotation. So every single rotation has to have a point where it rotates. So think about if you have this whole graph as a circle, then the origin is going to be the center of the circle, and so everything's going to rotate through around that point. Each figure in a rotation rotates at a specific angle and a specific direction. So the angle tells you how far you're going, and the direction tells you which direction the rotations are happening. We are only going to focus on counterclockwise rotations. So no matter how it's going, if you think we're going the opposite as the hands on a clock, so that's going to be going in this direction. So all of our rotations are going to be going like that. Though the figure can rotate around any fixed point, the most common center of rotation is the origin, and that's, like I said, the only one that we are going to focus on. There are, obviously you can rotate a figure at any angle. We are going to focus on 90 degrees, 180 degrees, and 270 degrees. So we know that there are 360 degrees in a circle. 90 degrees is going to be like 1/4. So if we start here at the x-axis and rotate up 90 degrees, we're going to end up here. So if we have our shape here, triangle ABC, and we rotate it 90 degrees counterclockwise, it ends up in the next quadrant over. If we go 180 degrees, that's going to go upside down, so into 2 quadrants over, and then 270 is going to take us all 3 quadrants. There is a rule for every single one of these. So when we are rotating 90 degrees counterclockwise, that's going to take our original points from our original, our pre-image, and that is going to send it to -y, x. So when we are performing a 90-degree rotation, a point that is at x, y will end up at -y, x. For 180 degrees, that takes xy to -x, y. And then for 270 degrees, that's going to take xy to y, -x. So you can see that 180 degrees does not change the order of your points, but it does change them to the opposite signs, whereas 90 degrees and 270 degrees does flip those points around, so y is going to come before x. Let's look at an example, and I'll just go ahead and show you what these are going to look like. That's going to be the best way to practice these. So 90 degrees counterclockwise is the very first thing that I want us to notice. And then next to this, I'm going to write the rule, which is my points are going to become -y, x. So I'm going to go ahead and graph triangle ABC. So A is at 2, 7. B is at 6, 5. And C is at 4, 1. These don't have to be super precise, but I am using a ruler just so that it looks nicer. Now, to figure out where the image is going to end up, the first thing I'm going to do is rewrite the coordinates using my rule of -y, x. So A was at 2, 7. So A prime is going to end up with -y comes first. Y was 7, so -y is -7, and then my x value comes second. So A prime ends up at -7, 2, which is going to be here at A prime. B prime is going to end up at negative, and then y is 5, and x is 6. So negative 5, comma 6. And make sure that you're labeling those points as their respective names, A prime, B prime. And then C prime should be at negative 1, comma 4. And there we go. So you can see that ABC was here, and then it turned around. So you see how A was at the top, but after it rotated, it ended up over there on the side. All right, let's move on and look at another example. This is going to be 180 degrees. So first thing I'm going to do is write out my rule, which is going to be negative x comma negative y, and then I'm going to go ahead and graph my square. So P is at 2, 6. Q is at 6, 5. R is at 5, 1. And S is at 1, 2. So there's my original square. That's my pre-image. Now I'm going to use my coordinate rule to write the image points so that I can graph it. So P, everything's just turning to the opposite. So since all of these are positive, they're all going to become negative. So P is at negative 2, negative 6. Q prime, excuse me, is at negative 6, negative 5. R prime is at negative 1, comma, or negative 5, comma, negative 1. And S prime is at negative 1, comma, negative 2. So then this guy's just going to end up looking upside down because we took it and we rotated it around. Just going to freehand this in real quick, and there we are. So because the rotation represents a turn, you can see how P was at the top here and then like R was at the bottom, but then in our shape, R has turned to the top and P has turned to the bottom. Alternatively, if I were to actually turn the paper and look at it this way, you can see now how my pink shape, my image, looks the same as my pre-image did when my paper was right side up. And that's because we turned it twice. So I turned my paper 2 times, and if I turn it 1 and 2, it puts it right back to where it was. Okay, we've got one more example that I'd like to do, and that is going to be 270 degrees. So 270 degrees, my rule is going to be y comma negative x. So I've got J is at 3, 4. K is at 6, 4. L is at 8, 1. And M is at 1, 1. It's a very perfect and precise looking trapezoid. Okay, now using my rule, we're going to end up at y negative x. So J prime, y is 4, and then negative x will be negative 3. K prime is going to end up at 4, negative 6. L prime will be at 1, negative 8. And M will be at 1, negative 1. Now, a 270 degree rotation is going to take my shape, which is in quadrant 1, and it should end up 1, 2, 3 quadrants away, which is going to be in quadrant 4. So as I'm graphing these points, I can double check that I used the correct rule by making sure that my points end up in the correct quadrant that they should be in. So I'm at 4, -3, so I'm already off to a good start. And that's going to be J prime. K prime is 4, -6. L prime is 1, -8. And M prime is 1, -1. So all of my points are in the correct quadrant. My shape is where it's supposed to be. It hasn't changed shape or size. It's just turned around a couple of times. And that's it. That's how you perform a rotation.